Welcome to the Energy Talk podcast. It's a pleasure to have you both on.
My name is Adrian, and I'm the CEO of Nimbus.
And I'm Akim, and I'm the CTO of Nimbus.
Excellent. So the way we usually like to do the podcast is how our guests got into their space. But I think a more interesting way to start this with you both is how did you both meet? What was that story?
Interesting enough, I was actually working at Bombardier, and uh, I've always wanted to do more. I wanted to be in a place where I can do a greater impact and have more responsibilities. And long story short, during that time, Adrian, as someone just reached out to me on LinkedIn when I called text on LinkedIn, and they were telling me about how there is a need on the regional jet and market, and how we could be the first people to start in that field. And I was kind of sold, and here we are.
What he doesn't mention in that is that he said yes before I was even finished pitching him. So I knew he was just the type of person, with the mentality required to jump into starting an airplane company. So
It seems like the stars really aligned for both of you during that time. So, Adrian, where were you at during that time when you made that pitch to Akim?
yeah, so I don't come from the aviation industry. I come from software. I was working as a product manager at a fintech startup. But I've loved airplanes my entire life. And essentially, like Akeem mentioned, through doing market research, we found out that there was a need to start an airplane company. And like I said, I've loved airplanes, and I just figured now would be the perfect time to try to start an airplane company. So that's kind of how Nimbus came to be. It wasn't like a very well thought out multi-year process. It was just sort of like, the timing is right, the technology's available, but I need someone with the engineering background to help bring this thing to market.
Interesting. So, when you both decided you wanted to do something in the aviation space, why did you land on the segment that you both have established? And maybe take a few steps backward first. First of all, what is Nimbus, and what are you trying to solve?
Yeah, so what we're building is a six-passenger light jet. So I don't know how familiar your audiences are with different private jet class sizes, but essentially it starts at the small end of very light, like the Honda jet, and then it goes up to the very large cabin, like the Gulfstreams. Our aircraft is on the smaller size. It's called a light jet, and really the light jet is more so for like regional transport. And the reason why we wanted to do the light jet market is because in the United States, which is where Nimbus is founded, about 36.5% of the market is made up of light jets, and around 80% of private jet trips in this country are serviced by aircraft within the light jet size. So that's where we landed on the light jet market.
Very interesting. And was it a fact that the market seemed ready in terms of the technology only, or did you see an actual commercial opportunity? I want to figure out if this came off from a climate change perspective, trying to push for sustainable aviation technology, or is it more of a commercial opportunity you both saw?
I guess like I can answer the business side question on this. It's a mix of both, honestly. So like as we mentioned, when we started Nimbus, it was for the sustainability reasons because the airlines have committed to net zero by 2050. Additionally, they're operating aircraft that are very old and bad for the environment and not using their mission profile, right? Now, when you think about selling an aircraft to a private jet owner, yes, sustainability is one of the issues that they do care about, but their biggest pain point is high fuel cost and high maintenance cost. So if you build a more sustainable aircraft, you burn less fuel, but also when you build a more sustainable aircraft, you remove the jet engines and replace them with electric jet engines, and you lower the maintenance bill. So really, you do solve both issues in terms of making it a better product for the end user, but while also making it better for the environment. So it's a mix.
And from the technical standpoint, it's more like the technology was actually available for hybrid electric, and looking at it more, the legacy companies have spent billions of dollars building their own infrastructure that's not tailored towards hybrid electric. And the beauty of us being a startup at Nimbus, we get to actually build that whole um, architecture from the ground up. So it gives us that chance to actually use readily available technology right now on the market that are ready to be certified and be put on the aircraft for the next generation aircraft.
Mm, that's very interesting. And for the sake of the audience and myself, quite frankly, what is the alternative aviation market like from a technology standpoint? So we understand the traditional aviation business, commercials, privates, most of them are running on jet fuel. What is the alternative technology looking like, and where does Nimbus fit within that scope?
Legacy manufacturers are pushing a lot more on the sustainable aviation fuel side of things. There's new formulas coming out every year for the new fuel system that's more sustainable. But even with that, it doesn't get you faster to the 2050 goal, green aircraft goal. So for us to get there, there has to be a big jump to the actual hybrid technology because it's ready and it's available.
Okay. Adrian, I think it's best if you come in here because what I'm trying to understand, and I'm trying to frame this for the audience as well, is you are doing hybrid electric. Where does the rest of the sustainable aviation technology sit, and why hybrid electric for Nimbus? What what led to that technology decision?
Yeah, I think so. Answering this question, I'm going to kind of toe a fine line here because I don't want to come across as I'm bashing any of the other companies. There are a lot of companies doing really innovative things in this space, whether they're building fully electric or hydrogen aircraft. The main reason why we went with hybrid electric is because it's the easiest type of aircraft you can bring to market that solves the most amount of pain points for the end user. So when you think about a hydrogen aircraft, the technology is available to build a hydrogen aircraft, just like it's available to build a fully electric aircraft. The difference is with hydrogen, you get the range. With electric, the batteries lack the energy density to get you the range. But both of those aircraft face major infrastructure readiness challenges as well as certification issues. So, like for example, in the United States, hydrogen probably would be the better option right now because it's the only one that can offer the range to compete with a gas-powered jet. But you're going to have major problems getting that aircraft brought to market. It's going to cost significantly more expensive. You don't have the infrastructure available. And hydrogen is quite expensive, right? So, in order to make it cheaper to operate, which solves one of the biggest pain points for current light jet owners, you need to create more hydrogen. Right now, we're trying to figure out how to create hydrogen at scale. So, there's a lot of issues involved with bringing these types of aircraft to market. Whereas a hybrid electric, like Akim was mentioning, we're using already available technology on the market. So, all we need to do is kind of put these parts together into our airframe, and we have an aircraft that is significantly more sustainable, much cheaper to operate and own, and it's kind of a plug and play solution. So an owner can just buy it and use it with the already available infrastructure on the market. And so that's really why we decided to go hybrid electric.
So, Akim, in terms of actually visualizing again for the audience, what those sustainability features are, in terms of operating a traditional jet versus a Nimbus jet, what do the key sustainability like high points look like in terms of numbers?
Numbers, you mean like the components we're actually going to use, like the engine, the turbo generator, the battery?
Yeah, I'm just trying to figure out if it's cheaper to operate, if you're spending net less on fuel versus charging, what that comparison looks like versus the traditional jets.
Oh, well, for one, an electric engine is much cheaper than a jet engine. So, b- buying, let's say for maintenance, there needs to be a replacement or like a piece that, like a bird got sucked into the engine and there is like shrapnel all over inside and it needs to be replaced. So, comparing a jet engine that just has, really expensive motor, but everything else is nominal in the engine compared to a jet engine that's built for like I think a jet engine costs like around like 1 point something $1 million, whereas when you look at like an electric engine is going to come like almost 80% less than that. So that's one of the numbers you look at and you're like, okay, this makes more sense. And then of course, the cost is going to come in later on the battery side because the battery is going to be need to be integrated. But also, it's still not going to be as expensive as it is for like a legacy aircraft.
But one other thing you have to mention is the amount of fuel you're putting in, right? Because since you have batteries in there, you use about 50% less fuel. So the tanks are much smaller as well.
Hmm. I'm curious how this takes into account the added weight of the batteries. Does that have any net negatives to how the aircraft actually operates, or what does that look like in practical sense?
So aircraft design is basically just a balance of multiple things, and one of them being weight. So when you start taking the weight of the battery, there is a lot you can balance to actually make up for that. Like one example will be the engine. A jet engine is much heavier than electric engine. It has less components into it. It has less sections in the engine, so that makes it a lot lighter. Even on the aircraft, you just have to balance and make sure you incorporate the battery weight into everything you're counting. It's part of basically the aircraft design. You look at the weight. That's when you can balance how many passengers can go on board, how much luggage, and how much you design the aircraft to actually be able to carry. Like you design it to have a specific max gross takeoff weight. And that's basically what we did. We just found a balance between all the weights that needs to be integrated into it.
And further, one further point on that is it's kind of another reason why we didn't go fully electric is because since, like we mentioned, batteries lack energy density, well, weight is a huge issue. And so if you wanted to build, like you could obviously just continue to put more batteries into an aircraft, right? But if you put in all those batteries in order to get any type of meaningful range on an electric aircraft, then you have major problems with structural issues if you have something like a hard landing or something like that. So, really, in order for an electric aircraft to work in the future, you need to really increase the energy density levels in batteries. And right now, it's just not there. So, we like to your point, weight is a massive issue, and that's why we kind of didn't really want to go electric or even try to make it plug-in hybrid or something like that.
This is the Energy Talk Podcast.
So now that we have a better understanding of the market and the technology, I want to get a sense of where Nimbus is at right now and get into a bit more details. But where are you guys at right now? At what stage is your product development and overall, what kind of response are you seeing?
Currently, we're building a proof of concept. Uh, we actually last week we just received from the fabrication labs we're working with. They've finished cutting up most of the parts. They've finalized the wing spars and wing assembly and with like all the tooling that comes with it. That's being shipped to us for assembly. They've finalized cutting all the fuselage components. That's also being shipped to us for assembly. We just finalized the design for an Iron Bird, which we're gonna uh, test all the avionics system and how they operate. So right now we're at the point where uh, we're on track to flight test a model early this coming year, and after that, that's when we're gonna navigate to the side where we're actually building a full scale model. So the prototype is a quarter scale. It's fully electric. It's running on battery. We didn't. That's one thing we didn't prototype. We're not prototyping the hybrid part of the propulsion system. Right now, we're focused on refining the aerodynamics to give us the specific design data we need for the full scale aircraft, and then we can integrate the propulsion system, the hybrid propulsion system.
Hmm. That's very interesting. And Adrian, I'm curious, with an idea like this, fundraising for hardware startups is notoriously very difficult. So, apart from the technology side, from the commercials and the fundraising part in particular, what were those early conversations like
With investors or with ourselves on the team?
with investors?
Well, I think a lot of investors, right when we announced Nimbus, before we had gone through Techstars, investors would reach out and kind of wanted to like gauge, are we crazy to try to start a company like this? As we've gotten further along, those conversations have now changed, and they're seeing the progress that we're making now. There's a lot of excitement, and so we're really looking forward to the next stages, as Akim mentioned, and bringing on some great new partners to accelerate our growth with Nimbus.
Mm. So I assume you're looking at investors outside of the equity bubble, what other kind of instruments are you looking at in terms of fundraising for that stage you're in?
Oh no, so right now we're venture capital, so venture capital and family office.
Okay.
As
All
we
right.
grow, we might do like debt financing, but in order to really take advantage of debt financing, we need significantly more LOIs in order to kind of hold that against the debt financing rounds.
Okay, that's excellent. And are you seeing more progress from the generalist investors? I asked this because on the climate tech side in particular, there are very few investors that even want to touch hardware businesses. So are you getting more traction from specialized VCs, or are generalist VCs also getting interested in what you're building?
I think it's a mix, and it's a good question because when it comes time to figuring out who actually wants to lead the round, then it's very specialized, right? Because in order to do the proper type of due diligence on this type of company, then you do need people, you need experts in your network, right? But in terms of follow-on investors, it tends to be more so generalists. So
Okay, that's very interesting. So you mentioned Techstars. Was Techstars really where you had the opportunity to really incubate of the idea? I know that they have invested. I don't know if that was the first capital you raised or if that was the second. But how important was Techstars in your development?
first of all, like Techstars, we didn't go to Techstars for the capital, right? We went to Techstars for the network as well as for the mentorship, and
Are
it
you sure?
oh, 100%. I mean, yeah, I don't think it's a good idea to go to any accelerator for the capital for that matter. But um, Techstars, we had already developed the idea for Nimbus and the business model. So really, we used it essentially just to have basically a 3-month sprint where we could just really focus on bringing something to market. And so in this case, we built the 1/10 scale models that we flight tested at the end of the program. And so for that, yeah, it accelerated our growth, right? So we did those models in 4 weeks. And then throughout that process, we were put in contact with some people that we still speak with today, mentor on a mentorship level. So I wouldn't say that we incubated the idea at Techstars. We more so used Techstars as a launch pad to kind of accelerate our growth into 2025.
Mm. And speaking of the accelerated growth, the milestone that you mentioned, your first test flight, which I think was with a smaller scale model. Akim, you can give a bit more details here. How was that cycle of production to actually get that first test flight done? And in terms of your internal milestone tracking, where does that sit?
Yeah, it was actually that was probably the fastest turnaround on a model I've ever worked on, whether it's like just as a hobby building a model or anything. But we were at a stage where uh, we had defined the market analysis on the mission profile we needed for an aircraft, and we had multiple concepts that could be applied to that, and we needed to build demonstrators to actually see the viability of that. And with those, we decided on two airframes, and which is, I guess, one thing the public doesn't actually know. We did build two models. We've always shown like one, which is the one we're most proud of, which I'll talk more about how it wasn't actually the best performing one. Um, but we were very proud of it. But we built two airframes, and then we were trying to test the viability of their flight. So the one that's really nice looking, it had a distributed propulsion system on top of the wing, and the other one was just a traditional with two tail mounted engines. So we wanted to see the viability because like the electric technology there was a lot of engines that were being built with like where they're really small, and we wanted to see how that can be applied to the aviation industry. So we did build, as far as I actually know, like a subscale prototype of a distributed system, which we tested against the traditional tail-mounted engine. And for that one, they both performed well. It was successful flights. Seeing that model actually fly and come in for a landing was, oof, it was a great moment. But we flight tested those, and looking at the data that came from both, the traditional tail-mounted engine was more viable because the distributed propulsion system, especially since now it's integrated into the wing, it puts a lot of complication. For one, like on the landing gear, there's going to be a lot of weight. If it's a hybrid electric system, so when it comes in for a landing, you did not lose fuel, so it comes in at the same max takeoff weight. So you have to worry about like a lot of landing gear structural issues. Also routing all those wire harnesses into the wing, that complicates the design. So we had to modify our airfoil shape to make it the camber a little thicker, so we can route the wiring in there. So it added a lot more complications than the traditional tail-mounted engines. Even on the performance side, it performed much better, like 3 times more, because the distributed propulsion system flew for like a minute and 30 seconds, whereas the other one flew for almost like 5 minutes, still had enough reserves. So the design and the airframe was much better. So that helped us decide on which path to take for moving forward for the next airframe.
Hmm. That sounds very interesting, and I'm very curious how big of a team you're working with. Is it still just the two of you running the core team?
No, at that time we were 3. Now we've expanded the team. We're, we're, we're 5 plus one more we just onboarded.
Well, okay. The growth is definitely exciting. So in terms of what you're working towards, Adrian, help me out here. What does a typical jet within the product category that you're building sell for? If you wanted to go out, you had like $30 million burning a hole in your pocket. Could I get you a decent one?
Yeah, I mean, I think it depends if you want to buy new or used, but for the best-selling light jet in the market sells for around $12 million, right, before options. Um, so yeah, 13 million, you could definitely get an aircraft. Our aircraft is going to sell for around 12.5, right? So uh, yeah, that's about, it's a good amount of money to spend on an aircraft. So be happy with what you purchase, especially if you buy one of ours.
Yeah. So in terms of milestones, what are you looking at next? I know that eventually there's going to be test flights for the one-to-one scale product, but in terms of milestones, what are you tracking internally, and what is like the next 2, 3 things you're looking at now?
I can answer that from the engineering standpoint. It's everything is geared to this flight test we're doing this coming year. So at the beginning of the year, there was a lot of leeway. Like we're working things parallel. Like there's still a lot of technology we were focused on the full scale model, but then we'll also still be working on the subscale model because that takes priority for it to validate what we need to do next. It also included, defining all our manufacturing capabilities, defining all these manufacturing processes, working with partners that are already agnostic in the industry and understand how the systems work, because we do want to build from the ground up with using new technology, but we also do value a lot of the processes that have already been set up, because that's what makes it much faster to certify. So as the next milestone, I think everything is built towards right now because we're very close to getting it flight tested. We're in the testing phase of everything right now. Like I said, we're building the Ironbird for test. We, I believe the test was complete this week. We've partnered with some universities to perform some testing on our engines. So I should be getting a report by next week actually from that. So that's also one other test we're doing. The other test is mostly like landing gear drop tests. We need to perform tests on that. That's actually what's coming in the next few months. In addition to everything else we have to support on the PR side of things. Maybe Adrian can handle that better.
I think, we did a really bad job with PR at the beginning of launching Nimbus. And I think the reason why I mentioned that is because I think a lot of people don't really appreciate the importance of PR until you find out that it actually is very important, right? And so one of our key objectives for this year was to basically just do a much better job of PR. In fact, do a better job than pretty much any other company at this stage building what we're trying to do it. So um, to that ends, we've really ramped up PR across social media, professional networks like LinkedIn, and then we've started to go into many more events. So like we had an event in London in September. We're going to Paris and holding an event at Station F, so one of the largest startup communities on earth, to talk about airplanes and AI and manufacturing. And then we're doing podcasts, right? And then later in November, part of our team is going to the Dubai Air Show, right? And so we're doing all these things to establish maximum credibility, but also just get the word out about what we're doing here at Nimbus. And so we think hopefully those will all kind of come together. And then as the 1/4 flies, we're going to have a really awesome video of the 1/4. Um, and really just that'll be like, I guess, our second coming out of stealth moment, but we're going to do it right this time. So.
Okay, very well said. And on that note, actually, what does the ecosystem look like in terms of support for Nimbus? You mentioned that there's a network of universities they're working with on the testing phase, but more broadly, what does your support ecosystem look like?
Um, there's a lot of collaborations we're working on, because the one thing that makes aviation companies successful is the collaboration. Because you can design your own aircraft, build your own engines, build your own avionics system, build your own propulsion system. All of that requires collaboration with multiple people, because if you try to do that yourself, each field probably takes 7 years to actually develop the design, develop, and then market, certify. So it takes so long. So for you to actually be successful, you need to establish collaboration with um, industry companies that understand how the industry standards are met, especially on the certification side, because there's always a governing authority that has to approve everything you do. So you establish partnership with a lot of universities that the relationship works both ways. We provide internships to students, and they get to work on the tests we're doing with them. So they get a little experience from that, but also that we get to work with their facilities. Like we get discounts on wind tunnels, we get um, all discounts on all the testing facilities we might need support for. So we're partnering with the universities, specifically Wichita State University and the University of Washington. Um, we are partnering with the fabrication labs, because as we prototype through this phase, yes, eventually in the future, we want to have our own manufacturing facilities. But at this point, to reduce cost and how much funding we need at this point and at this stage, we would prefer partnering with other industry savvy companies to establish that, and establish all our engineering processes and validate all our engineering designs and basically everything on the engineering side.
Hmm. And on the funding landscape, what is that ecosystem looks like? And as I assume you're looking to raise your next round.
Well, so we can't, we're in the process of raising a round right now, so we can't disclose the names of any of the investors. But it'll be, it'll be venture capitalists, right? And then there are a few angels in the mix, but for the most part, we anticipate about 95% of the round will be filled by institutional investors.
Okay. So as we get towards the end, there's a question I like to ask all the guests. And this is going to be especially interesting for you both because you're very early in your journey. With all you've mentioned about sustainable aviation and specifically of what you're building at Nimbus, how would you define failure in your work?
When you look at the aviation industry, a lot of the people in the industry all come from similar backgrounds and they all look the same. And that's not necessarily a problem. It's just when you want to make an impact in an industry, it is our belief that you need diversity in thought and leadership to have the most innovative products. And so our hope at Nimbus is that we're be a small part in that to make the industry more diverse. And I think if you don't do that, then I think that would be a failure because Akeem and I get reached out to people that look like us, as well as some women that are also reaching out to us saying, "I didn't know people like us could start a company like this." And that's not right, right? Because there's always going to be someone looking up at an airplane flying over, and I think representation matters, right? And so we hope that people will follow our journey. And when they look up at that airplane, rather than just looking up and dreaming, they'll look up and feel that they have a place in this industry. And so that's if that doesn't happen with this next round of airplane companies building sustainable products, and I think that would be a massive failure.
Well said. Akim.
I think coming from working in the legacy manufacturing industry, everything is specifically Bombardier, everything was very safe. Like everything was very standard. But when you transition to a startup world, you realize like a lot of people jump through a lot of loops. So I would honestly define failure as, when you're going through innovation and pushing the boundaries of the new technology, forgetting about safety. So safety is always the number one thing for me. When it comes to, even when we're flight testing or we're doing like a design change or a design balance, the first question I always ask, does this still meet the safety requirements for us to do this? So safety will be my answer.
Excellent. Okay.
This is the Energy Talk Podcast.